Welcome to this session. We are going to discuss about RAID in this session. In the earlier sessions, we have discussed about the magnetic storage devices. What are all the storage devices that we use? Magnetic disk, tape drives, properties of optical storage devices, and all these things we have discussed in the previous sessions. When we say we need to store, definitely there is a thing of taking backups of everything. So we need to have a larger space of memory so that we take backups of our data. So RAID is a storage structure which is used to ensure the reliability and the performance. So RAID, the full form of RAID is redundant array of independent disks. Earlier it was inexpensive disks. Now it is called as redundant array of independent disks. Storage, it is a storage technology that combines multiple disk drives into a single logical unit to achieve storage virtualization. So the concept of storage virtualization is very important. So it is achieved through this RAID. The example for the RAID are server computers and advanced personal computers can be taken as example for RAID. As I told you, reliability and performance needs to be improved for any system. So in such case, improvement of reliability is ensured via redundancy, and improvement of performance is ensured via parallelism. So when we see reliability via redundancy, we know that redundancy is repeating a data or making a copy of data more times is called as redundancy. So when we say redundancy, the data is repeated or the same data is stored many number of times. So this redundancy is achieved through mirroring and shadowing of data. The performance of parallelism, the performance is improved via parallelism. It is achieved through bit level stripping and block level stripping. Stripping is nothing but distributing the data. So when we say RAID is a redundant array of independent disks. So the name itself specifies that it has redundant array, and it is a storage technology that combines multiple disk drives into a single logical unit to achieve storage virtualization. Examples are server computers and advanced personal computers. Reliability and the performance are the main thing that needs to be improved. So redundancy is improved. Reliability is improved with the help of redundancy. Performance is improved via parallelism. So to improve the reliability, we go for mirroring and shadowing, and to improve the performance, we go for bit level stripping or block level stripping. So there are some 8 levels of RAID that we have: RAID 0, RAID level 1, 2, 3, 4, 5, 6 and 1 plus 0. So these are all the different RAID levels that we have. Let us discuss about each one of this. As we have already seen, to improve reliability we go for redundancy, and for improving performance we go for parallelism. So when we say we need to improve these two, as I told you, mirroring, shadowing, bit stripping and block stripping are the techniques that are used. So in case of RAID 0, they use the concept of block stripping, where stripping at level of blocks, meaning which there are number of blocks, the data is stripped between the blocks. So that technique is used here to improve the performance. RAID 1 is having the concept of mirroring, that is redundant data on 2 disks. Say for example, I have disk 1 and disk 2. So this is disk 1 and disk 2. When we say redundant, the same data is present in both the disks. Likewise, whatever may be the data that we have, it is copied, or a copy of that data is also maintained in one more disk. That is called as mirroring. Whatever that we hear is the same thing, we have it here. And when we say RAID 2 is memory style error correcting codes with bit stripping, meaning which the data is stored in terms of bits. When it is stored in terms of bits, when the bits are transferred to disks, we need to check for the error correction, meaning which the parity bit, whether whatever that we sent is actually stored. So in such case, these error correction codes and memory style error correction codes are very much helpful in that. and bit interleaved parity, which is also ensuring the interleaving of bits between the devices. And block interleaved parity is for the entire block of data, not by considering only the bit. RAID 5 is block interleaved distributed parity, where the parity bit is distributed between the disks. In case of block interleaved parity, the parity bits are stored in one disk, and in that we will have all the parity bits. But whereas in case of block interleaved distributed parity, the parity bit is distributed on all the disks. So whatever the data that is stored, that disk will itself have the bit block interleaved parity. And level 6 is P plus Q redundancy scheme, where it is also a redundancy technique which is used like mirroring to improve the performance of reliability. RAID 1 plus 0 is nothing but mirroring and stripping. So once if we distribute our data between two disks and we mirror the data in more number of disks, it is helpful for us to rely on the data which we have. But still, having all these done, when we think of this, it takes a longer time, and the cost involved in this, when we get into the concept of big data, the amount that we spent on this, the cost will be very high. So in such case, when we go for when we need to improve the reliability and parallelism, we have to improve the performance and the reliability. So we see for parallelism rather than going for redundancy. So this is about RAID. We will discuss about the indexing in the next class.